Hello guys, welcome once again to Valeto's Maths Academy. Our purpose is to bring mathematics to you in the most simple and understandable way. Okay, and today we'll be looking at arithmetic progression, AP, and geometric progression, GP. Do well to follow the channel, to like and share the video so that we can promote mathematics together. All right. Under arithmetic and geometric progression, we'll be looking at how to get any term at all in the arithmetic term or geometric term. Okay. So we'll dive into the course. Our learning objective for this course will be to understand arithmetic and geometric sequences. We'll apply formulas for the nth term, that is any term at all. That's what we mean by the nth term. And the sum of a number of terms. Okay. Then we'll solve real life problems on sequences. Then engage in our normal interactive tasks. All right. So what do we understand by arithmetic progression? What do we understand by arithmetic progression? Let's deal with arithmetic progression first before we go into geometric progression. So by arithmetic progression or arithmetic sequence, we mean any sequence where the new term is gotten from or by adding a constant number to the preceding term. For instance, we have an example here. 2, 5, 8, 11. Now, we call the first term, this is a sequence. A sequence is something that is flowing by consistent intervals. Okay, that's the simplest way I can put it for now. All right, so it's but there are two types of sequences for our level right now, is the arithmetic sequence and the geometric sequence. But the arithmetic sequence is got by the addition of a constant number to the preceding term. So if the first term here in this sequence is 2 and the next term is 5, the difference between 5 and 2 is the constant we are talking about. That is what determines whether it is an arithmetic sequence or a geometric sequence, the way we derive the next term. So for arithmetic sequence, we say that it is derived by adding a constant number to the preceding term. So to know the number that has been added here, we can easily say 5 minus 2, and that is equals to 3. If we want to know if the number is constant, we do the next thing. 8 minus 5, this is equals to 3. 11 minus 8 is equals to what? 3. So you see, this is a sequence. It is got by adding a constant number to the preceding term. Okay, for arithmetic sequence, we can call the first term A. All right, is equals to the first term. Then this difference 3, we can call it the common difference D, which we can call the common difference. All right, so in this example here, this is the first term, 5 is the second term, 8 is the third term, 11 is the fourth term. We can easily derive the fifth term. If this is the first term, this is the second term, this is the third term, this is the fourth term. We can easily derive the fifth term by adding the common difference, which is 3. So the fifth term here now will be equal to, what's the fourth term? 11 plus 3, which is equals to what? 14. So we can easily say the fifth term here will be 14. Okay, so in arithmetic progression, purpose of this class is to know how to derive any term at all. For instance, if we are told to find the 20th term in this progression, in this sequence, we should be able to look for it at the end of this course. Okay, now how do we do that? To find any term at all in a sequence, in an arithmetic sequence, we use the formula nth term is equals to a plus n minus 1 times multiplied by d, which is the nth term is equal to the first term plus the number of the term you want to look for minus 1 multiplied by the common difference. Okay, all right, let's try an example. Let us look at this example with us here. So in this example, we are told to look for the 10th term of the sequence 2, 5, 8, 11. Remember that 2 is the first term, 5 is the second term, 8 is the third term, 11 is the fourth term. So we are told to look for the 10th term. So the 10th term now, using our formula, will now be where a is equals to what? The first term, and the first term here is 2. And the common difference, what else do we need in the formula? The common difference is 3, like we have gotten here. And so we're looking for the 10th term. The 10th term, we don't know what it is, okay? So what we can say is the 10th term, or n, we can denote it by T10, is equal to what? The first term is what? A. A is, the first term is 2. 2 plus n minus 1, which is 10 minus 1, multiplied by d, and d is what? The common difference, which is 3. Okay, so we have the 10th term will be 2 plus 10 minus 1 multiplied by 3, and 10 minus 1 is 9 times 3 is what? 27 plus 2 is equals to the 10th term. Okay, so we can say the 10th term is equals to what? 27 plus 2 is equals to 29. All right, so in this sequence, if we are to keep on adding, the common difference of 3, the 10th term will be 29. So here we have 14. 14 plus 3 will be 17. 17 plus 3 will be 20. 20 plus 3 will be 23. 23 plus 3 will be 26. 26 plus 3 will be 29. So let us see. This is the first term, second term, third term, fourth term, fifth term, sixth term, 7, 8, 9, 10, 29. You see that? And that is what we have as our answer here, 29. So instead of giving you the time, taking you the time and stress of adding the common difference continuously, you can use this formula to get the any term at all in a sequence, in an arithmetic sequence. All right. For instance, if you are told from this same sequence to derive the 20th term using the same formula, all you have to do is to derive the 20th term will be equal to the first term, which is 2, plus 20 minus 1 multiplied by the common difference, which is 3. This will give you the 20th term. And this is the same thing as 2 plus 19 times 3, 57. And the 20th term is the same thing as 59. Okay? It's so easy. It's so easy. You don't need to run away from mathematics anymore. Here, we make mathematics as simple as possible. All right? Please always share to promote the knowledge. Okay? We continue. Okay, before we continue, let's look at one more example. Supposing I just opened a blank screen to help us do another example. Supposing we are given a sequence 3. The first term is 3. The second term is 7. The third term is 11. What kind of sequence is this? Is it an arithmetic sequence or a geometric sequence? How to know is to check the common difference. If the common difference is constant, by adding the same number to the preceding term, you know it's an arithmetic progression. All right. So 7 minus 3 is 4. 11 minus 7 is 4. Okay, so this is an arithmetic sequence. So we say that the first term A is 3, very important. The common difference D is what? 4. All right. I will say to get the nth term of the sequence, Tn is equals to A plus n minus 1 multiplied by the common difference. So if this is true, from this sequence, if we are told to calculate find the 50th term, Now, obviously, if you are going to keep adding 4 to each of these term, to the preceding term, you're going to get the 50th term eventually, but it's going to take you a lot of time. So the easiest way to do it is by applying this formula. So we say that the 50th term will be equal to the first term 3 plus 50 minus 1 multiplied by the common difference. It's so simple and easy. So 50 minus 1 is 49. 49 times 4 is 196 plus 3. This is the same thing as 199. So the 50th term of this sequence is equals to 199. You can do the maths, check if we're correct. Okay, we move on. Okay, another thing we could be asked is to find the sum of a number of terms in a progression, either in arithmetic progression or in a geometric progression. But for now, we're talking about arithmetic progression. So if, for instance, if we're told to find the sum of the first terms, the sum of the first 5 terms, for instance, of this sequence, How do we do that? The sum of the terms of a sequence, sum of terms of an arithmetic progression, is given by, let's say Sn, sum of terms. Now let us say denote it as Sn. We could get it by dividing the number of terms we are told to get by 2 and multiplying the first term by 2, then you add it to the number of terms minus 1 multiplied by what? The common difference. Yep. This should give you the sum of any number of terms you want. So if we're told to find in this sequence 3, 7, 11, and we're told to find the sum of the first 5 terms. Okay, I don't want to use a very large number because I want us to do it manually, and also by the formula. So the sum of the first 5 terms now will be, let's say S5, sum of the first 5 terms. We're looking for first 5 terms, so n here is equals to 5. Okay, we'll say where n is equals to 5, a is equals to what? The first term, which is what in the sequence 3. D in the sequence is the common difference, which is what? Remember, to know the common difference, you subtract the next term from the preceding term, which is 7 minus 3, which is equal to what? 4. Okay, so to know the sum of the first 5 terms will now be, n is 5, so it will now be 5 over 2 into 2 times a is 3, plus n minus 1, 5 minus 1 times what? The common difference of 4. Okay, so 5 over 2, half of 5 is 2.5. We can say 2.5 multiplied by 2 times 3 is 6, plus 5 minus 1 is 4. 4 times 4 is 16. Okay, so the sum of the first 5 terms will be equal to 2.5 times 22, and that is the same thing as what? That should give us 55. So the sum of the first 5 terms is equals to 55. Now let's put our answer to the test. Let's check if what we have done is correct by adding it manually. All right, so we see here that the first term is 3. I'm picking from the equation, so our check now. The first term is 3, the second term is 7, the third term is 11. What will be the fourth term? We get the fourth term by adding the common difference, which is 4. So 11 plus 4 is 15, and the fifth term will be what? Plus another 4, 19. Okay, so let's see if we sum up these 5 terms, these first 5 terms, and see if it's going to give us 55. Okay, if it gives us 55, then we are good. If it doesn't, then I have to apologize to you. 3, so we add 3 plus 7 plus 11 plus 15 plus 19. Okay, I'm getting 55. 3 plus 7 is 10. 10 plus 11 is 21. 21 plus 15 is 36. 36 plus 19 is 55. So that justifies the use of this formula. So instead of taking your time, supposing you are told to find the sum of the first 20 terms, it's going to take forever to get that. So that is why the use of this formula is important. So if we're asked to find the sum of the first 20 terms in this equation, it's going to take us forever to get it. So that is why the use of that of this formula is very important. Okay, we move on. Find the sum of the first 20 terms of this sequence. All right, so we have said that the sum of terms is the same thing as n over 2 into 2a plus n minus 1 multiplied by the common difference. Okay, so here in this equation, the first term is 4, second term is 8, third term is 12. So where n is equals to 20, a is equals to, what's the first term here now? 4. And the common difference, 8 minus 4 is 4. Common difference, d, is equals to 4. All right. So let's add something to this equation. Also find the 15th term. Okay. So we're told to find the sum of the first 20 terms and also find the 15th term. Okay. Remember, to find the sum of the first 20 terms and to find the 20th term are two different things. Find the 15th term and the 20th term. Okay, we'll do this now. So please bear in mind, to find the sum of the first 20 terms is different from to find the 20th term in a sequence. They are two different things. All right. So we move on. From the equation, S20 now will be equal to 20 over 2 into 2 times 4, which is the first term, plus 20 minus 1 times what? 4, which is the common difference. And S20 is the same thing as 10 into 2 times 4 is 8 plus 19 times 4, 76. Okay. And then S20 is equals to 10 times 84, which should be 840. So the sum of the first 20 terms should be equal to 840. Then question 2, we're asked to look for the 15th term. And how do we get the 15th term? We say that in any term, okay, the 15th term, let's say T15, is equals to a plus n minus 1 d. So the 15th term here will now be, the first term is what? 4 plus n minus 1, 15 minus 1 multiplied by 4, which is the common difference. So 15 minus 1 is 14 times 4 is 56 plus 4. This will give us our 15th term. And our 15th term is the same thing as 16. Okay? Then we're also told to find the 20th term. The 20th term will now be T20 is equals to a plus n minus 1 multiplied by the common difference. So the T20 here will be the same thing as 4 into 20 minus 1 multiplied by 4. So This will be same thing as 20 minus 1 is 19. 19 times 4 is 76. 4 plus 76, which is equals to 80. Yep, is equals to 80. All right, so you see that the value of the 20th term is 80, but the sum of the first 20 term is 840. So please, anytime you have to deal with sequence, do not mix up the question or the understanding. All right, now let's look at geometric progression. When we talk of geometric progression, what differentiates it from arithmetic progression or arithmetic sequence is the difference. In arithmetic sequence, we call the difference the common difference. And the common difference is gotten by subtracting the next term from the previous term or the preceding term. But in geometric progression, what we have is called the common ratio. And the common ratio is got by multiplying a particular number by the preceding term. Okay? For instance, we have 3, 6, 12 here as our sequence. To know the common ratio, you have to divide. Since you are getting it by multiplication, you have to divide now. 6 divided by 3 is equals to 2. 12 divided by 6 is equals to 2. So 2 becomes our common ratio. So to know the next term, it has to be multiplied by 2. So 12 times 2, the next term here will be 24. So let's see if it's correct. The next term, 24 now, divided by 12 is equals to what? 2. The next term here will be what? 24 times 2, 48, and so on. So this is geometric progression. It multiplies itself. Arithmetic progression adds itself. Just know that geometric progression multiplies, arithmetic adds. In arithmetic progression, we talk about the common difference. In geometric progression, we talk about the common ratio. Okay, so we look at this question. Now to get any term at all in a geometric progression is different from the arithmetic progression. For the geometric progression, to get any term at all is let's say Tn. To get any term, be the 10th term, 20th term, or anything, is the first term multiplied by the common ratio raised to power n minus 1. You remember when we did our indices, exponents, yeah? So a, which is the first term, multiplied by the common ratio exponent n minus 1. N is the number of term or the term you are actually looking for, minus 1. All right, so let's put this to the test. So the application of this will now be, let's if they say find from this sequence, now find the 6th term. We have gotten the 5th, 4th, 5th, and 6th term. Find the 6th term. Find the 6th term. All right, okay, so the formula says a raised to power ar raised to power n minus 1. So to get the 6th term, this would then be, the first term is what? 3 times what? The common ratio is what? 2 raised to power n minus 1. 6 minus 1 is 5. All right, so 2 raised to power 5 is what? Remember, in our indices, you say 2 raised to the power 5 is not 2 times 5. Please, if you've not seen our class on indices, please do well to go back and look at our lectures on indices, because maths is linked to each other. Everything in mathematics is linked. Yeah. And it gives you a better foundation when you have the elementary knowledge. All right. Okay. So remember that 2 times 5 is different from 2 raised to the power 5, 2 exponent 5. All right. So 2 raised to the power 5 is should be 3 times 32. Okay. 2 raised to the power 5 should be 32. 2 raised to the power 5 is same thing as 2 times 2 times 2 times 2. 1, 2, 3, 4 times 2. 5 times. It is different from 2 times 5. So 2 times 5 is 10. But 2 raised to the power 5 is 2 times 2 times 2 times 2 times 2, which is 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. That's how we got this 32 here. So our sixth term in this geometric progression will be 3 times 32. Okay, and this will be 96, right? I think so. Okay, so that's to get for any term in a geometric progression. So let us see if what we have done here is correct by doing this manually. The first term here is 3. The second term is 6, gotten by multiplication. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is what? 96. So these are first term, second term, third term, fourth term, fifth term, and our sixth term. So, and that is our sixth term here, 96. Okay. So if you are told to get the 20th term, you cannot keep multiplying by 2. You just have to use this formula and apply it. All right. So we'll look at the sum of terms in a geometric progression, in a geometric sequence. The sum of terms in a geometric sequence is denoted by Sn, or we can denote it by Sn, and it is given by this formula: A into r raised to the power n minus 1 all over r minus 1. Yep, that's correct. R raised to the power n minus 1 all over r minus 1. Yes, let's apply this and see if it's correct. So the sum of the first of any number of terms in a geometric progression, this should be good enough to work it out. All right. So we'll put it to the test. To apply this, let us look for the sum of the first 4 terms in this progression. We'll do it manually, and we'll do it by the formula and see if we get the same thing, then we are good. So we use the formula first, then we'll go into the manual process. So this is the same thing as A is the first term. What's the first term here? 3 into, just substitute all the numbers for the letters, all the letters for the numbers in the formula, and you get your answer. Okay, so this is 3 into, the common ratio here is what? 2. Yep, 2 raised to power what? Sum of the first, find the sum of the what? How many terms are we looking for? Sum of the first 4 terms. Okay, we're looking for, find the sum. Sum means addition. Sum of the first 4 terms in the GP, in the geometric progression, or in the sequence. Okay, so we apply the formula. First term is 3, common ratio is 2 raised to power 4. 2 raised to power 4 minus 1, all over what? R minus 1, which is R here. The common ratio is 2 again, minus 1. So this is the same thing as 2 minus 1 is 1. So we don't need to write that. This is the same thing as 2 raised to power 4 is 2 times 2 times 2 times 2, which is 2 raised to the power 4, 2 times 2, 4, 4 times 2, 8, 8 times 2, 32. That's 2 raised to the power 4. Same thing as 32 minus 1 times 3. So we have that the sum of the first 4 terms is equals to what? 3 times what? 31, which is what? 93. Okay, so now let's do it manually and see if it's correct. So picking the sequence to check our answer, we see 3 plus 6 plus 12 plus 24. Hold on. 2 raised to the power 4 is 2 times 2 times 2 times 2 into 4 places, which is 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16, not 32. Okay. 16 minus 1 is 15. 15 times 3 is 45. So this should be 45, not 93. Sorry. 45, yeah. So 2 raised to the power 4 is 16. 16 minus 1 is 15. 15 multiplied by 3 will give you 45. Okay, so we put it to the test. So we want to find the sum of the first 4 terms. This is the sum of the first 4 terms, 45. So we want to do it manually to see if it's correct. So the first term is 3, second term is 6, third term is 12, and the fourth term is 24. Okay, so we add 3 plus 6 is 9. 9 plus 12 is what? 17. Nope. 21. 21 plus 24 is 45. So there you are. That's the manual application of it. So if you're told to look for the first 20 terms in a geometric sequence, you cannot do it manually. You have to go by the formula. So it's good to add here that this is for a finite sequence, geometric sequence. Is for a finite sequence. But if the sequence is to infinity, it is easier to solve such. If you are told to find the sum of such a sequence, it is easier to get that by, let's say, infinity. This is the sign for infinity. It should be you can just get that by dividing the first term all over 1 minus r, and that is if r, you can use this formula if the common ratio is less than 1. Okay, but if the common ratio is greater than 1, then you have to use a all over r minus 1. Okay, whichever is applicable. All right, this is very simple. it's not something we should take our time on. Okay, so that's it for sequence. We'll just look at all these questions. Find the sum of the first 5 terms of geometric sequence 2, 4, blah blah blah. Okay, we apply the formula like we did previously, which is 2, 4, 8. So what does the formula tell us? The sum is equals to the first term into r minus 1 all over r minus 1. Okay, and this is the same thing as we're looking for the first 5 terms, the sum. This will now be where the first term here, a, where a is equals to what the first term, and the first term here is 2. The common ratio is gotten by dividing, remember. So we say 4 divided by 2 is 2. Common ratio is 2. 8 divided by 4 is 2. So you know it is common to in the sequence. So we have that 2 bracket common ratio is 2 raised to power what? The first, how many terms are we looking for? S5. Okay, so raised to power 5 minus 1 all over r minus 1. R is 2. 2 minus 1. Okay, so this is the same thing as 2 raised to power 5 should be 32. 32 minus 1 is 31. 31 times 2 should be 62. Okay, 2 minus 1 is 1. So right, so the sum of the first 5 terms in this geometric sequence is 62. All right, we move on. Find the 15th term of the sequence 7, 10, 13. The common difference here, is this a geometric sequence or an arithmetic sequence? You have to know the progression by the common difference or the common ratio. 10 minus 7 here is 3. 13 minus 10 is 3. So it's a common difference. Please note the difference, okay? It's not a common ratio. All right. So if we're told to find the 15th term of this sequence, it is, we apply our formula. T15 is equals to, this is an arithmetic sequence, so we use the arithmetic formula. A n minus 1, you should have this formula in your head. This is the same thing as the first term here is 7 plus, we're looking for 15th term, 15 minus 1, and the common difference here is what? 3. This is the same thing as, so the 15th term now will be 15 minus 1 is 14. 14 times 3 is 42. 7 plus 42. And the 15th term will be 49. Okay. Here we have our practice questions. Number 1, find the 12th term in this sequence. They are all very easy. Just apply the formula. The first thing to do is to be able to differentiate between a geometric progression and an arithmetic sequence. All right, remember the geometric progression deals with common ratio, which is gotten by dividing the next term by the preceding term, and an arithmetic progression is gotten by the common difference, is denoted by the common difference, which is got by adding or by subtracting a particular number from the preceding, from the succeeding term, or in other words, it's gotten by adding a particular number to the preceding term and you get the next term. Okay, that's the difference between common difference and common ratio. Feel free to pause the video at any time to solve the questions. Let me see your thoughts on the comment section. We have an interactive task as usual. Feel free to pause the video and solve at your own pace. Okay. Number 2, this is a multiple choice question. What is the sum of the first 4 terms? 2, 4, 6, 8. Remember, the sum of the number of terms is different from a particular term. This is a true or false answer. True or false question. The common ratio of 3, 9, 27 is 3. True or false? So the purpose of all these interactive tasks is not for you to just skip them, it's for you to work on them and get confident. Yeah, you may think you know them, yeah, that's fine. But by the time you do them again and again and again, you'll find that you become conversant. It becomes part of you. You now have an understanding, a deeper understanding with the topic. All right. So we've come to the end of this lecture. In summary, sequences can be arithmetic or geometric. By now, I believe you know the difference. The difference is always from the common ratio or the common difference. Okay. Use formulas to find any term at all you want in a sequence, be geometric, and you can also use formulas to find the sum of any number of terms. Remember to identify the common ratio or the common difference. That is the key to differentiating arithmetic progression from geometric progression. Continue to practice and practice. Pick up any maths textbook available to you. Mathematics is the same everywhere in all languages. And mathematics is constant. So please follow. Let's promote mathematics together. Follow the channel, like, share, and subscribe. Thank you so much. I'll see you in our next class.